I'm Bob Hendricks, CineDown.com, and I'm here with Anthony Gramani, who is president of PMI. Anthony, we're in a showroom that you engineered in Southern California that belongs to Audio Images, a company with whom you work. And here we can actually see some of the components that you use in the installations and some of your techniques that you use to do the installations that we've seen for the last couple of days. Maybe you can give us a couple of the details without giving all of your know-how to our readers out there.
Yeah, sure, Bob. Right now we're looking at the front wall of the room. The screen has been removed, and the typical fabric that hides all these loudspeakers have been removed, so you can actually see what's behind the fabric, essentially what's under the hood. So here's the center speaker that is behind the acoustically transparent screen. It's placed vertically, and it's actually mounted in a baffle, what's called an infinite baffle. And in our case, one of our elements of know-how is the baffle is curved. Now, this baffle gives lots of advantages. One of the advantages is that all of the bass sounds are actually focalized forward. They're actually dispersed into the room forward as opposed to back behind the speaker. The other advantage is we actually gain in sensitivity, gain in efficiency for the speaker. That means the speaker doesn't have to work quite so hard. We also apply some absorption on the front face of the baffle to control this element called diffractions, high-frequency diffractions, and eliminate them. Result is the sound is clearer, the bass is tighter, the speaker is working more efficiently.
And in fact, by doing that, you can actually move the speaker back against the wall so we gain space.
That's right. Audiophiles know that you never want to put a speaker up against a wall. You always pull it out into the room, and you end up using you lose 3 or 4 feet of the room. By putting a baffle around the speaker, now you can push the whole thing back up against the front wall and gain back that real estate that you would have lost.
Well, it's your engineering that knows how to calculate that curve, because these are actually curved because each installation is rather unique.
Right. So every room needs a different design. For every room we have to calculate the diffusion factor of that curve and specify that. We put it into the plan set and the builder implements it, and in the end the sonic qualities of the speakers are totally optimized.
Over on this wall we see some of the other products that you use. Maybe you can give us a demonstration and explanation of those.
Sure, Bob. Let me show you that. So Bob, here we are in front of the right wall of a room. In this case, the decorative fabric, the acoustically transparent fabric, has been removed so we can see what's behind the hood over here. So first thing we see over here is an absorber panel. Most good home theaters have those, but this one's very special. It's actually 6 inches thick, and it's that thick so that it treats and absorbs a wide range of frequencies. Now, there's not absorber panels everywhere. There's just a few. They're strategically located in the right place, and a number of them is calculated through our engineering process. We don't want to over-absorb the room, otherwise it's going to sound dead. It won't be very engaging. Now, in addition to these absorber panels, we also have some diffusers over here. This panel over here is called a 2D diffuser. The sound that hits it actually is redistributed the room. It's scattered into the room in a 2-dimensional plane, and it gives you a sensation of smooth sound presence from your sides that makes you feel like you're in the sound field, and it opens up the width of the soundstage. So in addition to the 2D panels over here, we also have some 3D diffuser panels. 3D diffuser panels take the sound vector that hits them and redistributes them hemispherically in a circular form. And what that does is it gives you a sensation of envelopment out of the surround speakers and out of the back quarters of the room. We typically tend to put those towards the back of the room and the 2Ds towards the front of the room.
And over here you have a bass trap. We've seen those on the lateral walls and also in the floors. Maybe you can give us some details on that.
Right. So absorbing and controlling bass is a complicated thing, and for every room, with its unique characteristic, we figure out what frequencies need to be controlled. Every room has some kind of frequencies where the resonances are terrible, and we trap those by using these special perforated devices. There's a strategy at where we put those. There's a strategy at where we put the absorbers. There's a strategy as to where we put the diffusers. That's all calculated in the engineering and measured in the room, and then we place them all correctly.
And also with these, you see the distance between the holes. It's just not perforated board. That is also calculated as part of the engineering, depending on the installation.
Absolutely. These are custom perforated. The enclosure depth, the position of the holes, everything is all figured out based on what the room needs. So this isn't just regular pegboard. This is actually hand drilled, and the actual distance of the holes and the depth and all of that is figured out relative to the needs of the room.
Anthony, thank you very much for sharing your knowledge with us, and thank you for showing us some of your installations and what we don't see in the installations, in fact.
Thank you, Bob.
Thank you.